And now, before diving into the science of the critical zone, we would like to give you an overview of the progress made in setting up the European eLTER research infrastructure that Ari already introduced. So Jaana Bäck from the University of Helsinki, Department of Forestry, who has been working for over 10 years with Michael Merton from the Austrian agency and the German Helmut Center on the establishment of eLTER, will present this overview. So Jaana, the floor is yours.
Thank you very much, Isabel, and thanks for giving me the floor to give you a small insight on the letters that have already been mentioned a couple of times in these introductory talks, the eLTER research infrastructure. And eLTER stands for Integrated European Long-Term Ecosystem, Critical Zone and Socio-Ecological Research. So you know that the name already has critical zone as a very elementary part of the infrastructure. I'd like to introduce you a little bit like the background, and then go into a deeper couple of examples for scientists that we can say that eLTER can provide services for. First, you see here a map of Europe, and all the bright blue colors mark the countries that have committed or are currently on their way to commit to building and operating the infrastructure. So it's currently more than 20 countries, and in those countries about 250 sites and platforms are hosted and operated already now. The habitats that are covered are terrestrial and freshwater and transitional waters habitats, and there is also a very strong socio-ecological component involved. The formal structure looks like this, and I will go a bit later into both sides, the right-hand side and the left-hand side, what they mean for researchers. But the purpose of eLTER in short is to enable the research and analysis of complex interactions and feedbacks in the systems, both fast and slow interactions. eLTER wants to work across the spheres of ecosystems, from the weathered bedrock and groundwater up to the lower atmosphere, including the anthroposphere or socio-econosphere. And we want to work with climate change, land use change, pollution, eutrophication, biodiversity loss, the critical global challenges that are facing the globe at the moment. eLTER also does research on the socio-ecological implications of these changes and how they could be mitigated now and in the future. eLTER will support research and observation by providing long-term observations, both currently ongoing, but also legacy data that is coming from even a century ago. It will have a nested design of its site network. It will address simultaneously the many drivers and over a range of temporal and spatial scales. And we have worked all along, like 10 years or more, with the whole system approach, which we understand to cover all the different spheres that you can see here in these disks. The geosphere, hydrosphere, biosphere, and atmosphere. And in the anthroposphere, everything is then combined together. The water, matter, energy, and information flows connect these spheres, and the forcings and feedbacks are then leading to changes in one or another. And this is what eLTER wants to address and help people, help researchers to address. What we have been doing together with you, many of you, is that we have been creating a framework of standard observations. And our framework currently covers roughly 65 different variables in these 5 different spheres. Depending on which category the sites are located or identified, they will need to observe either 35 to 45 observations or standard observations, or if they are less heavy in observation framework, then there might be only less than 30 for the category 2 sites. I'll give you a couple of examples that might be closest to you. Geosphere and hydrosphere standard observations. So the geosphere observation list looks pretty small, but in fact it's quite a comprehensive one, and it covers from the inventory to the current status and changes in, for example, physical, chemical properties, sediments and infiltration. Of course, hydrosphere and geosphere are very closely connected, so the standing waters, running waters, surface waters, and groundwaters, they all will be intensively observed in the physical and chemical components, but also for example, water level, micropollutants, carbon, stable isotopes, and so on. And also glaciers. Some sites are located in glacier areas where, of course, the observations of glacier fronts or mass balances have to be conducted. These standard observations can be compared to the so-called essential variables, and this is what we did in an analysis that I'll show you now. There are essential variables for climate, for water, for biodiversity, for geosphere, and for ecosystem services. And a long list of these essential variables can be composed. When we look at the eLTER capacity of addressing these essential variables, you can see from the color coding that the darker the color in each of these essential variable lists is, the more comprehensively or fully they are covered. So, for example, from the essential climate variables, eLTER standard observations cover almost 60%. For the geodiversity variables, half. For the essential water cycle variables, about 80%. So we can say, maybe concluding from this, that our attempt to create a sustainable and comprehensive framework has at least shown its power in when we compare it with these essential variable concepts. Let's have a short look of the site categories, and this is the national research infrastructures that we are looking at, the eLTER in situ facilities, which is eLTER sites and LTSER platforms. We have categorized them into two, both sites and the platforms. So the site category 1 will have to cover the standard observation framework with basic methods for all of these 5 spheres, and it has to select 2 of the spheres where it does intensive and more comprehensive methods for assessing these observations. Whereas the lighter version of the sites studies all the spheres with only the basic methods, which are not very light. I must say they are also quite demanding. And for all the sites that are listed or committed, it requires comprehensive assessment, what is currently done, what needs to be upgraded, and how these upgrades will be then fed to eLTER databases, for example. We also did analysis of how capable eLTER is to address continental scale questions. And there are 2 papers currently out and 1 more in the pipeline of becoming published very soon, which addresses the fitness of this network to cover these challenges that are approached in our frameworks. And you can see from the color of the dots here that the areas where there is darker red or orange color are less well covered by our network, which is these blue dots here, whereas in yellow parts we do quite well. And if you look at the concentration of the site network in the Central Europe, the Alpine areas, northern Italy, Germany, you must, of course, we must say that there's quite a dense network there. Whereas in France, for example, there is already orange at some places where more sites could be established if in the future. In the Arctic areas, there is a clear gap. In the Mediterranean, the Spanish gap is evident, and in the Eastern Europe also there is a gap. Then some examples of how eLTER addresses scientific questions. The understanding of Earth system dynamics depends on the development of models and other analytical tools that apply physical, biological, and chemical data. The paper by Roland Barthes et al. Took an approach to analyze what kind of data exists and where are the complementarities. And for example, for comparing the critical zone and the eLTER, international eLTER network, there seems to be a kind of dichotomy. So the critical zone has different variables, different data sets than the biota analyzing infrastructures. So there is a clear request of cross-domain data sets that take into consideration both the biota and the physical and chemical parameters. This is why eLTER is so importantly needed. Communities have to be brought together and talk and collaborate so that we can address these questions more properly. Another example is from my country, in Finland, where we had a project using 2 eLTER sites in the central Finland, addressing where the priorities of conservation of biodiversity or conserving the carbon stocks and increasing carbon sinks could be combined. So what would be the areas where we have to focus if we want to address both of them? And we can see that there are clearly areas where biodiversity is already quite well covered, very few unluckily, and also where there are high carbon stocks, but they don't overlap. So there are these kind of balanced priority areas that we could emphasize and we could bring out for stakeholders and decision makers, that these would be the areas where both goals, biodiversity conservation and the carbon stocks, could be easily or relatively easily addressed at the same time. Another example comes from Bavaria, where the Bavarian National Park did a long-term research on benthic invertebrates, and they came up with a conclusion that the decline of air pollutants and the occurrence of bark beetles actually had an interactive relation. So this led to overall increase in this invertebrate abundance over 173% over a long time period. This analysis would not have been possible without having these 20 or 30 years data sets. And the third result is, I'm showing it very quickly now, is from Austria, where in Söbelboden catchment area they analyzed the nitrogen deposition and the losses of nitrogen to the groundwater and leaching to runoff and so on. And they came up with a conclusion that the trees could take up about 50 kilos nitrogen per year per hectare in those areas, which is an important factor in conserving the groundwater and keeping the nitrate levels in the groundwater in a level which is tolerable for the authorities. My last slides are then a message from last summer. I saw many of you in Tampere in the science conference, and I'm happy to see you again here. I just wanted to bring you the outcomes from this conference that we organized, and it was a very successful one because we collected about 350 people together for a 4 days period from 37 different countries. We also did a carbon footprint assessment. Isabel was mentioning that this is also a goal for OZCAR and TERENO Conference. So we did an assessment, and our venue was very very proactive in this, so that the Scope 1 and Scope 2 carbon footprint was zero, because they did what they could do to avoid any carbon losses or carbon emissions, and they also compensated what could not be avoided. So the only thing that was remaining for the carbon footprint was the travel of people to Tampere, which was of course quite a big sum in any case, but we encourage people to compensate your travels if anyhow possible. One slide only about the future services at the centralized level. So we have ongoing now currently topic center calls. The 2 first ones have been opened in August and they will be closing in November. And there will be several others coming still this year. And I know that the French communities have been very actively thinking and developing concepts where this could be maybe offering an opportunity for the French community also participating. So my main messages are that we are on the way of becoming an ERIC. The structure is becoming consolidated. The site and platform characteristics and standard observations are already agreed, and countries are anticipating what is there for them. So there's a wide range of scientific and operational benefits at different scales. It's an integrated joint endeavor. Without you, it would not succeed, because we need scientists who use the services, develop them together with each other. And it's also a good example globally for the eLTER network, international eLTER network. This is one of the flagship initiatives that is always mentioned. There are several steps ahead of us. There's continuous negotiations with experts and funding shareholders in all those 20 countries. Potential to involve more. Next science conference in 2027 should be started planning, and there are rumors that some candidates already exist. And the step 2 of the ERIC is anticipated next year. And my last few lines are here. So I really want to appreciate Jérôme and Harry for bringing OZCAR and Tereno together and highlighting what eLTER can do to these communities. And the second thank you is to all of you who have participated in eLTER projects, especially those who have participated in the standard observations protocol writing. That has not been a small task, so I'm highly appreciating all the efforts that have been done by you and this community. Thank you very much.